Hello kids, this is day 2, March 31st, 2020 of week 1. And again, please be safe, please be vigilant, do what your parents instruct you to do so everyone can stay safe and healthy, okay? Let's jump into this math. Today we're on 157 and page 158. Addition twins. Let me explain that. Everything that I'm reading, again, it is in your packet. I'm just reading from what's in the packet to work a few of the problems for you so you can understand what's going on, okay? Okay, the order of the add-ins can be changed without changing the sum. And the add-ins, remember, are the numbers that you're adding together because it's addition. And the answer is called the sum. See how the words are coming back? And I instructed many weeks ago that the book has stopped saying, well, let's add 4 plus 4. They are saying now the add-ins, which are the two numbers added, and the sum is the answer. Okay, so they're giving an example of some dice. One has a 5 showing and one has a 7 showing, so they add it together. 5 plus 7, as you know, is 12. And on the other dice, is showing that 7 is the first number, 5 is the second number. So what happened, they switched. Don't let that throw you, because if 7 plus 5 is 12, 5 plus 7 is 12, just like multiplication. If 4 times 2 is 8, 2 times 4 is 8. If 5 times 7 is 35, 7 times 5 is 35, okay? Just remember that. Now, the class practice, write yes if the problem in an example of the add-ins being changed without changing the sum. So, the first one, like I just said, they have 7 plus 2 equals 7 plus 2. So, did the add-ins change? No, because I read 7 plus 2 equals 7 plus 2. They did not change, but they changed up here in the example because first it was 5 plus 7, then it was 7 plus 5. That's all you do. It's as simple as that. All right, moving to number 2, solve the story problem. To solve a story problem, to see which mathematical function needs to be used, you need to find the clue words. That's the important thing in story problems, are the clue words. They will inform you of addition, subtraction, multiplication, division. When it asks for how many in all, how many are left, those are clue words. Okay, let's do A. Mr. Tetlow went to the store. He bought nails for $5.78, okay? Wood for $45.78, and paint for $18.25. How much money did he have left? Listen to this. How much money did he have left from $70? Now, the first thing we know, listen to that clue word. That clue word is how much money left. So obviously, and they gave us the amount of money he started with was $70. So if you have $70, if you go to the store with $70, if you buy 3 different items or 3 items of the same thing, you know that the price of that merchandise is coming from that $70, right? Right. So you would have to do what mathematical function? Absolutely. You would have to subtract. But first thing we're going to do is to find out how much has to be taken from this $70. So what we do, we add $5.78, $45.78 plus $18.25. We total that together, and when we total that together, then we subtract it from the $70. So how much did he spend in all? He spent $69.81. If you add all that together, it's 69. It comes to a total of $69.81. All you do is line it up. You say, not forget the dollar sign. I'm only going to write the the dollar sign, marker went dry, let's try another one. I'm only going to write the dollar sign once instead of being repetitive, okay? Okay. Guys, I'm having a problem with my marker. But anyway, the total is $69.81. So, if you subtract $69.81 from $70, so how much would be left? All he would have left from $70 is 19 cents. But to put 19 cents into perspective, dollar sign, decimal, 19. That's how you represent 19 cents pertaining to money. And then you will write the word left out to it to let us, the teachers, know that, okay, it's 19 cents left. Okay? Okay. So, moving on to number 3. We will have to look at what we're doing because here we're doing some conversion problems, okay? Which A states 7 quarts plus 3 pints equal 17 pints, right? Okay, so when we do the 7 quarts plus the 3 pints, thank you. When we do the 7 quarts plus the 3 pints, this is what we're going to have. We're going to have 7 quarts. Oh, this is a good marker right here. 7 quarts plus 3 pints. Okay? And that will equal blank pints. Okay? But remember, our steps, we have 3 steps to this. So, in the book, they have, well, let me write the other. They have 14 quarts. I'm sorry. They have 14 pints. They have 14 pints plus 3 pints equals 17. I'm just going to go on and put that answer in there. All right? All right, look right here. This is what they are working with. They're working with this part right here. You have quarts to pints. Now, if you're working from quarts to pints, you're working from larger to smaller. Remember? Larger to smaller. Okay, I'm showing you. The answers are here. I'm going to show you how I got the answers, okay? We're working from larger to smaller. Here, it has 7 quarts, but down here, it has 14 pints. So if it's larger to smaller, we know our mathematical function is what? Multiplication. So right here, we're going to multiply. Okay? And our special number will be to say how many pints are in a quart, which we automatically know that because you all can just roll it off your tongue, how many pints in a quart, which we know our special number will be 2. See? Our special number will be 2. And since we know our special number will be 2, so we take, this is our problem. Now we set up our equation. I think equation sounds much better than problem. We set up our equation, which will be 7 times 2, which is our special number, equals 14. Okay? So look right here. We have 14 pints plus 3 pints. Remember, the 3 pints came, because this is the original equation. We had to convert quarts to pints because we're going from larger to smaller. And larger to smaller, you multiply our first function. Then we had to find our special number. And our special number is 2 because there are 2 quarts, 2 pints equals a quart. Okay, so 7 times 2 is 14. Now since these two are the same, 14 pints plus 3 pints, 14 plus 3, that's how I ended up with 17 pints. Got it? Absolutely. You all know this like the back of your hand. As a matter of fact, I get so thrilled and happy just to see you all working these problems, because it's just like I can just see the wheels turning in your head. Now, at the bottom of page 157, we have a review. Place the commas correctly. Read each number. All this is they have a number like 55, 6, 1, 5. And you know you count from right to left over 3 places and you place your comma. 1, 2, 3, comma. It falls between the 5 and the 6. The second 5 and the 6. Okay? Going into page 158. Divide and check. You all are so good at dividing. These are single numbers. I will work the first one because it has your nemesis in it. And your nemesis is that blasted 0. So, I'm going to put, when I erase this, I will write A for you. And we will work it. We're going to conquer the 0 one day. We had 7 into 5,407. Okay? Guys, I think you can see better if I work from this side. Sorry about that. If you look at this equation, look at this first number. Anytime your divisor is larger than the first number, you cannot divide the divisor to that number. So when you move over a number, it's no longer 5. It becomes a double-digit number, which is 54. Now 7 can go into 54 7 times. It wouldn't go 8 because 8 times 7 is 56. I know you guys know that. So it would be 7. And remember our 5 steps to division. I may be out of your view, but remember our 5 steps to division. Divide, multiply. 7 times 7 is 49. Then we subtract. 9 from 4 you cannot take. So you have to come over to the thousands place because this is 5,407. Take 1 from that 5, make it a 4. Add it to this 4 to make it 14. 9 from 14 is 5. All of that subtracting, and now you're looking at it to see, what do I need to do next? Which is comparing. That C is for the 4th step. Okay? So, you bring this 0 down. 7 into 50 will go 7 times again. 47 times 7. Brought it down. 7 times 7 is 49. See how you just repeating the steps over and over? Divide, multiply, subtract, which I'm getting ready to subtract. I can't take 9 from 0, so I have to borrow 1 from that 5, from that 50 to make it a 4. Add it to this 0 to make it a 1. Now I can subtract. 9 from 10 is 1. You have a positive 4 and a negative 4, you know they automatically cancel each other out. So, after comparing, the next thing I do is bring down. I bring down that 7. Now, that may not look like an arrow, but that is an arrow. I would say now, how many times would 7 go into 17? I would say 2, because 3 times 7 is 21. That's too big. So, I would do 2, and I would place my 2 above the 7. It goes above the number that you're dividing the divisor into. Okay? Multiply 2 times 7, 14. Subtract, step 3, which is 3. What do I have to compare? All I know is 4 from 7 is 3. What do I have to bring down? Not a thing. Let me see if it stays to check. Yes, it does. So, will come right here, I will take my quotient, 772, times my divisor, which is 7. 2 times 7 is 4. 7 times 2 is 14. Right on 4, carry on 1. 7 times 7 is 49, plus 1 is 50. I write my 0, carry on 5. 7 times 7 is 49. 49 plus 5 is 54. My remainder 3, my remainder 3 is add. 3 plus 4 is 7. I bring the 0 down, I bring the 4 down, I bring the 5 down. So, count over 3 places, and I should get my answer that I began with in my problem. Okay? So, that is number 5, divide and check. Number 6 are our variables, which is, I will do one of those to help you out as well. You are really not needing the help because you all really work these well. I have C minus 6 equals 7 plus 5. What we're solving for, we're trying to solve for this variable right here, which are usually alphabets, right? So, I like to work this side first. We know this is 12. Everything else comes down. My equal sign, my 6, my minus sign, and my variable. So, if I'm trying to get this variable to itself, what can I do to have this variable by itself? Now, in my head, if I have a negative 6, I know that a negative 6 plus a positive of that same number will cancel each other out. So I know I will have to add a positive 6 here. But don't forget, if you add a positive 6 to one side, you have to add a positive 6 to the other side. See? Positive 6, negative 6, they cancel each other out. You bring that variable down, C equals, and you add this equation, 12 plus 6, 18. Now that we know what the variable is, you know, I'd like for you guys to come right up here, plug it in, put it in parentheses, because we will rewrite this problem. This is the old equation. Now here's the new equation to check it, since we know what C is. 18 minus 6 equals 7 plus 5. 6 from 18, 6 from 8 is 2, bring the 1 down, equals 7 plus 5 equals 12. And it should always check. Both sides should always be the same. Okay? Piece of cake. You all can work it. Number 7, write the number for these number words. Okay, number words. You have to pay attention. You all mess up on this and it blows my mind. I'm thinking the thing that will be tough for you, you get it like a snap of a finger. But to write the numbers as number words, it throws you. So, the first one is written in words, 6,474. Listen to what it's saying. 6,000. Just write the numbers and do the commas last. 6,474. See? 6,474. To put the comma, you work from right to left. 1, 2, 3, comma. And that's the answer. And homework, which you know is no homework. I do not give homework. We work the clocks and time or the little puzzles in class. So we have clocks here, and all you do is set the time. Guys, this is a breeze. You all will do so well on this. And like I said, in the packet, I have on a blue tablet paper my name and telephone number. Have your parents, listen to Miss Janie, have your parents call Miss Janie if you come across a problem, and I will be more than happy to help you. Guys, stay safe and be blessed. See you next time, okay?